Calorimeters and transfer of heat. So if we have a glass of water and we put a hot metal object inside of it, we know from experience that that metal object is going to get colder, the water around is going to warm up. This is a property of chemistry. This happens because of the law of conservation of energy, which tells us that energy or heat cannot be created nor can it be destroyed. So when we place that hot metal in cold water, well, what happens to the heat? Well, it's going to leave the metal and it's going to go into the water. So let's go from the metal into the water. So what gains the heat? Well, the water is going to gain the heat. What loses heat? Well, the metal is going to lose heat. It's going to go down and how hot it feels. Well, how much heat does that water gain? Well, because of our law of conservation of energy, our water can only gain the amount of heat given off by the metal. That's all the more it can gain. So the Q of our metal, the heat given off by the metal, is going to be equal in the amount of the heat given to the water. Now remember, if our heat's given off the metal, this is going to be a negative value, and the heat absorbed by the water is going to be a positive value, but the amount of which is the same. Our negative and positive just tell us direction. Well, what is going to be the final temperature of the water compared to the metal? Well, eventually it's going to have to stop. And it'll stop when they become even in temperature. Therefore, one is no longer colder than the other one. So the final temperature of both, the temperature of the water and the temperature of our metal, their final temperatures are going to be equal.